Hello, and welcome to Mr. Wiley Teaches Math. Today we're going to talk about relations as ordered pairs. A relation can be expressed as an equation, in words, as a table of values, or as a set of ordered pairs. Our goal today is to go from an equation to ordered pairs. So the first equation we're going to work with is x plus y is equal to 8. So in other words, the sum of x and y values is 8. We could change this equation around and make it a little bit easier to work with. We could subtract x from both sides, and we could say y is equal to 8 subtract x. That might make it a bit easier to work with. It'd be the same thing, they'd be equivalent equations. To take this as an ordered pair, I'm going to take my equation, y is equal to 8 minus x, when x is equal to. Sometimes I'll have some values already in the table of values that I'm asked to use, and sometimes I can just choose. In this case, I'm just going to choose a number, and I'm going to choose a number that's fairly easy to work with. Let's start with 3 and say that x is equal to 3. So y is equal to 8 minus 3, y is equal to 5. So the ordered pair is 3 and 5. If we put that back in the original question, 3 plus 5 is equal to 8, or 8 minus 3 equals 5, and in that case it works. So we found our first ordered pair, which we write as 3 and 5. Ordered pairs are always written with the x value first, a comma, and then the y, all contained within brackets. We're going to need another value here, so let's try our original equation again. Y is equal to 8 subtract x, when x is equal to, and I get to choose another value. Let's go with 2, when x is equal to 2. So y is equal to 8 subtract 2, y is equal to 6. My quick check, 2 plus 6 equals 8. Yes, that looks like it works out. So my ordered pair is 2 and 6. And I'm going to need a third value here. Y is equal to 8 minus x, and let's make it when x is equal to 1. So y is equal to 8 subtract 1, y is equal to 7. So my third ordered pair is 1 and 7. Later lessons we'll look at how ordered pairs are locations, and these would be locations on the x-axis and locations on the y-axis to give me a point. So there's a point in this at 3 and 5, 2 and 6, 1 and 7. And as you can probably see from the table of values, there's a pattern to it. And later on when we draw this out on a graph, we'll see the pattern there as well. For now, let's move on to another equation. Y is equal to 2x plus 1. So this is already in the form where y is equal to, which is usually a little bit easier to work with. So the y values are equal to the x values multiplied by 2, then 1 is added. So I'm going to start with my equation. Y is equal to 2x plus 1, when x is equal to, and I get to choose a number. Let's go with 0 this time, when x is equal to 0. So y is equal to 2 multiplied by 0 plus 1, y is equal to 1. So there's my first ordered pair, 0 on the x-axis and 1 on the y-axis. And to do this again, y is equal to 2x plus 1, when x is equal to, well, let's go for a 1, when x is equal to 1. Y is equal to 2 times 1 plus 1, y is equal to 2 plus 1, y is equal to 3. So my second ordered pair is at 1 and 3. I could do these with negative numbers as well. So I take my original y is equal to 2x plus 1, and let's go with x is equal to negative 1. So y is equal to 2 multiplied by negative 1 plus 1, y is equal to negative 2 plus 1, y is equal to negative 1. So negative 1 and negative 1 are also a pair. So in later lessons we'll go through and we'll put these on a graph. We'll put these on the Cartesian plane and graph them out with a line. We'll find out the pattern, and in each of these cases it's going to be a straight line. Thanks for watching. Be sure to check the class website for handouts, additional examples, and the assignments.